Hi, my name is Struan and I'm a scientist at Eyes on Science, and today I'll be walking you through troubleshooting the most common problems during training on your Exoid. The first things to check if your baseline trace looks different to those shown during the demonstration videos is if everything has been set up correctly. Check that your pour is loaded with the serial number facing up and is attached to all four jaws of the stretcher unit. The pour has been stretched, the voltage is turned on, you have measurement electrolyte in the lower fluid cell, and either measurement electrolyte or sample in the upper fluid cell. The shielding cap is on, the pressure nozzle is inserted, a pressure is being applied if required, and always remember to close the lid for measurements. If your baseline has become a flat line at about 178 nanoamps, this is called a saturated current because this is the limit of detection for the current VCA settings. Lower the voltage to reduce the baseline current back inside the detectable range, remembering to aim for your current to be around 120 nanoamps plus or minus 20 nanoamps. A saturated current may also be caused by rogue liquid in the system. If your baseline has dropped to zero, become unstable or noisy, or has dropped partially and is no longer detecting blockades, there is either a blockage in the pour or a bubble that is preventing or limiting the current travelling through the pour. When this happens, tap the pressure nozzle firmly with the back of the pad 2 to 3 times a few seconds apart to stabilise the system like so. If the system is still unstable after tapping, you will need to dislodge the potential blockage or bubble. Perform the following actions in order until your baseline has returned to being stable, with an RMS noise value less than 15. First, apply maximum negative pressure to the system of negative 2,500 pascals for 30 seconds. Second, with negative pressure applied, tap the top of the pressure nozzle firmly with the back of the pad to shock the system in order to dislodge the bubble or blockage. Don't hit too hard, but use enough force that it registered as a large blockade on the trace. Tap between 5 and 10 times a few seconds apart. Third, set the pressure to 0 and remove the pressure nozzle. Then plunge with the pad, again between 5 to 10 times a few seconds apart. Fourth, load your pipette with 35 microliters of sample, or whatever is currently loaded in the upper fluid cell, and pipette mix the upper fluid cell. Taking care not to dispense this extra 35 microliters into the upper fluid cell once the mixing is complete. The fifth step is to stretch the pour up to 50 millimeters stretch and tap the pressure nozzle with the back of the pad to try and dislodge the bubble or blockage and stabilize the current. You may also need to reduce the voltage to see the effects of this step, as your current may saturate. If the baseline hasn't stabilized, replace the sample in the upper fluid cell with fresh measurement electrolyte. Stretch your pour to at least 47 millimeters and apply a maximum positive pressure of 2,500 for at least 30 seconds. You might need to tap the pressure nozzle firmly with the back of the pad to stabilize the current. Next, apply the maximum negative pressure of negative 2,500 pascals for 30 seconds. Again, you may need to tap the pressure nozzle sharply with the back of the pad, as this can dislodge any blockages or bubbles from inside the pour or around the pour entrance. Then, repeat the plunging step and the pipette mixing step with measurement electrolyte loaded in the upper fluid cell. The final step is to reset up your entire system. Remove and clean the upper fluid cell, then dry with a Kim wipe or nitrogen gun. De-stretch and remove the pore, cleaning with DI water and drying with a Kim wipe or nitrogen gun. Then dry the lower fluid cell gently with a Kim wipe. Then reassemble your system with fresh measurement electrolyte in both fluid cells. You can replace the fluid in the upper fluid cell with sample once you have re-established a stable baseline current. If your system is still unstable, then it is likely that the sample has caused a major blockage in the pore. To rectify this, you'll need to put the pore through a cleaning step by replacing the fluids in the upper and lower fluid cell with DI water and applying 2,500 pascals pressure at a stretch of 50 millimeters until the current is below 5 nanoamps. You may need to refresh the DI water a few times to achieve this. As this cleaning is quite time intensive, you may want to instead try the measurement with one of the other NP250 pores in your training kit for now and wash the blocked pore at a later time. If your pore cannot be cleaned and is irreversibly blocked, you will need to use another pore anyway. These steps should be used in the order presented if your baseline becomes unstable at any time and tapping the system with the hard side of the pad has been unsuccessful. Once your baseline becomes stable again, you can stop at the point you were on. There is no need to keep trying to stabilize the system. If the system destabilizes again, try tapping the pressure nozzle firmly 2 to 3 times to stabilize the system. If this does not work, then start the process from step 1 again. We will now go through some common scenarios that occur during training and how to fix them. If your baseline is jumping wildly or has high levels of RMS noise, this can indicate bubbles in either the upper or lower fluid cell. If the instance is in the upper fluid cell, you can try plunging the system with the pad 5 to 10 times, followed by pipette mixing, as I explained earlier. If there is no improvement, remove the upper fluid cell and wipe away the liquid on top of the pore. Then inspect the lower fluid cell for the presence of bubbles such as these ones. If bubbles are present, you will need to reduce the stretch, remove the nanopore, wipe it and the fluid cell clean, and reset up the nanopore. If your baseline drops sharply during measurement, say from 120 nanoamps to 105 nanoamps, this is either due to a partial blockage or a bubble somewhere in the system. Follow the step-by-step instructions to remove a bubble or blockage from before to recover your baseline. If your baseline increases significantly suddenly and now has a much higher current at the same voltage and stretch as before, even after the system has been reset up, this indicates that the pore has ruptured and become larger. If the pore rupture is significant enough, the pore will no longer be able to detect small particles and you will need to use another pore. If you observe blockades when no sample is loaded after cleaning the system 2 or 3 times, you may have contaminated your working PBS with your sample or calibration particles. Clean the entire system with 70% ethanol, including the pore and around the base of the pressure nozzle. If you still see blockades, then filter a fresh sample of PBS from your stock solution through a 0.22 micrometer syringe filter. If your trace freezes at any point, click on the connection button displayed below the Exoid. If you have expanded the view to full screen, click on the reduced screen button to see the connection button again. Disconnect the VCA by clicking disconnect. Wait until the VCA disconnects, then click on connect. Your trace should start working again. When you are loading solution into the lower fluid cell, it may overflow back towards the pipette and out of the fluid channel. Mop this liquid up with a tissue as it can create a short circuit in the system between the lower and upper fluid cells without going through the nanopore. This can lead to current saturation. If you see your current change by more than a few nanoamps when you insert the pressure nozzle, there may be liquid on the end of the pressure nozzle, causing a minor short circuit. Wipe the pressure nozzle dry with a Kim wipe, or remove the nozzle by unscrewing the base. Pull the tube off the bayonet, clean the nozzle with DI water and blow dry with a compressed air gun. If the system detects a leak when applying a pressure, The pressure will attempt to apply again once you have acknowledged the error message and clicked the red icon beside the pressure display. If the alert appears again, check that the pressure nozzle is fully inserted into the upper fluid cell. If the alert persists, try applying pressure while covering the tip of the nozzle with a finger or thumb and applying full pressure. This will tell you if the leak is in the fluid cell side or the tubing side. If the system holds pressure, check the O-ring for any damage or deformation, as this is the likely cause of the leak. Contact your local Izon rep for replacement O-rings. Whenever you see the baseline drop during a measurement, quickly select the pause button to preserve the quality of your data. If you do not select pause, your data will appear to have a large gap in it where no blockades are recorded, making it hard to compare particle rates accurately during the analysis step. If you have been able to correct the problem without resetting up the pour, click Resume Analysis. Otherwise, select Restart Run to restart the current measurement again. If you need to repeat all measurements in a calibration or sample run, select Cancel, then when prompted to make a calibration or measurement again, select Yes. One final tip. If, like me, you forget to remove your nanopore but have closed the ECS, you can use the down arrow button to de-stretch the unit and remove your nanopore without opening the software again. Please contact us at support@izon.com for more information or if you have any questions.